Just when you thought we couldn't do any more exponents, there is in fact a little more to learn. So let's check out 5.6, which is 0 and negative exponents. So our learning goal for today is to apply properties of integer exponents to create equivalent expressions. You are probably getting used to seeing this learning goal. So let's check it out. We're going to skip over this warm-up and do that together in class. So let's review. In an earlier lesson, you had learned how to divide expressions with the same base, such as this, where we have base of 4. We can use that same property to examine and justify a special case. So let's say, for example, we are looking at 4 cubed divided by 4 cubed. That means that 4 is a factor 3 times, so 4 times 4 times 4, and the same in my denominator. Well, I know that anytime my numerator and denominator are the same, that simplifies to one whole. Similarly, if I use the property that we learned with dividing with the same base, 4 cubed over 4 cubed means 4 to the third minus 3. So when I simplify that exponent, I get 4 to the 0 power, which seems crazy, but as we just demonstrated, 4 to the 0 power would actually simplify to 1. So we could say that 4 cubed over 4 cubed equals 4 to the 0 power, which equals 1. And that is in fact our 0 exponent property. In arithmetic, or just looking at it with numbers, it looks like this. A base of -3 raised to the 0 power equals 1. In algebra, when we're looking at it with variables, for every non-zero number a, so as long as a itself is not 0, our base isn't 0, when we raise it to the 0 power, we also get a value of 1. So let's look carefully how we can simplify here a bit. On letter A, I have the same numerator and denominator, which my instinct tells me should simplify to 1, but let's take it step by step. 18 divided by 18 is 1, because both of those will divide by 18. X to the 20th over x to the 20th, my property says the base is the same, so I can subtract my powers. So this really reduces to x to the 0 power, which we just learned is 1. Okay, but let's check out letter B. I have w to the 8th, z to the 15th, divided by w to the 8th, z to the 8th. So let's start by simplifying my w's. I have the same base, which is a w, so I can subtract the powers. 8 minus 8 is 0. And with my z's, I have the same base, so I can subtract the powers. 15 minus 8. So w to the 8 minus 8 power would be w to the 0 power, and z would be raised to the 7th power, because 15 minus 8 is 7. I can simplify further because anything raised to the 0 power is 1. So this is really like 1 times z to the 7th, which is z to the 7th. All right, and let's check out letter C. 9x to the 5th, y to the 12th, all divided by 3x squared, y to the 12th. So I'm going to start with my coefficients. 9 divided by 3, I know that this, so I wanted to use green. We'll cancel. 9 divided by 3 is 3. 3 divided by 3 is 1. Now I have x to the 5th divided by x squared. So I'm going to do x to the 5 minus 2 power and y to the 12 minus 12 power. So nothing's left in my denominator except the 1. So I'm going to keep my 3 in the numerator, and x to the 5 minus 2 becomes x cubed. Y to the 12 minus 12 becomes y to the 0. And I know that anything raised to the 0 power is 1, so I can simply write this as 3x cubed. Awesome job. Now let's check out letter D. I have 5x to the 0 power. Remember, my exponent only applies to what it's touching, which in this case is the x. So I have 5 times x to the 0 power. Well, x to the 0 power is 1. So this is really 5 times 1, or 5. It is time for you to try one on your own. So go ahead and pause the video and check out -3 6/10 to the 0 power. Well, you've probably already done so because anything to the 0 power equals 1. I knew you'd be good at this. All right, you can also use the property for dividing powers with the same base to examine and justify another special case. So let's say I have 8 cubed divided by 8 to the 5th. Let's expand that, and that means that 8 is a factor 3 times. 8 times 8 times 8. In my denominator, 8 is a factor 5 times. 8 times 8 times 8 times 8 times 8. If I want to cancel from top to bottom, I can cross out this pair of 8s. 8 divided by 8 is 1 over 1. I can cross out another pair of 8s, which also cancels to 1 over 1. And I can cross out a third pair of 8s, which cancels to 1 over 1. So all I have left in the numerator is 1, and in the denominator I have 8 squared. So this is what 8 cubed over 8 to the 5th power simplifies to. But let's check out our property. My property says when I'm dividing powers with the same base, I can subtract the exponents. Well, 3 minus 5 is -2. So 8 to the -2 power simplifies then to 1 over 8 squared. So this negative exponent takes my base and the power and moves them to the denominator. So I could say that 8 cubed divided by 8 to the 5th equals 8 to the -2 power, which simplifies to 1 over 8 squared. So in arithmetic, or with numbers, as we've just seen, 8 to the -5th power would simplify to 1 over 8 to the 5th power. In algebra, or when I'm using variables, as long as my base is not 0 and n is an integer, then a to the -n power equals 1 over a to the n power. So it's always just moving our base and the exponent across the fraction bar. So let's try a couple here. I have 2 to the 8th divided by 2 to the 11th. So my property tells me that I can keep my base and subtract my exponents. So you might remember from a previous lesson we said we always subtract in order from top to bottom. So 8 minus 11 would be 2 to the -3rd power, which would simplify to 1 over 2 cubed, and 1 over 2 cubed is 1/8. Let's check out letter B. 100b to the 50th divided by 200b to the 75th. So as I simplify, I know that 100 and 200 can both divide by 100. So my denominator would simplify to 2, my numerator would simplify to 1. And now I have the same base, and I'm going to subtract the exponents. So I have 1/2 times b to the 50th minus 75th. That would simplify to 1/2 b to the -25th. And my negative exponent will simplify by moving the b, my base, and its exponent to the denominator. So this becomes 1 over 2b to the 25th power. Let's try it out in letter C. A to the -3rd times b to the 7th times c to the 5th, all divided by a to the 5th, b squared, c to the 7th. So let's start with my a's. a to the negative third minus 5, b to the 7th minus 2, and c to the 5 minus 7. Let's simplify. Negative 3 minus 5 would be negative 8, so I have a to the negative 8 power. 7 minus 2 is 5, so I have b to the 5th power. And 5 minus 7 is negative 2, so I have c to the negative 2 power. As I simplify my negative exponents, a to the negative 8th becomes 1 over a to the 8th. b to the 5th stays as is, and c to the negative 2 power moves it on down to my denominator. So to simplify a little further, I don't need to say 1 times b to the 5th. I can just say b to the 5th over a to the 8th, c squared. You guys are getting into some pretty good algebra. You should be feeling good about yourselves right now. All right, letter D. I notice right off the bat I have parentheses, and that's significant because that means I have to apply this exponent to each part of this expression in here. So I'm going to do, I'm trying to use blue here. So I'm going to do 2 to the negative 2nd power times x to the 3. Now here I'm doing power of a power, so 3 times negative 2. And again with my y term, I'm doing power of a power, so y to the negative 5th times negative 2. So as we simplify 2 to the negative 2nd power, this would become 1 over 2 squared. X to the 3 times negative 2, that becomes x to the negative 6th. And negative 5 times negative 2 becomes y to the 10th. So let's finish simplifying to get rid of my negative exponents. And I have 1 times x to the negative 6th. So this x to the negative 6th will move to my denominator. In my denominator, I already had 2 squared, which is 4. I don't need to list this 1 again in my numerator because 1 times anything is going to be itself, and I'm still going to keep my y to the 10th in my numerator. So once again, my 1 became unnecessary because 1 times y to the 10th is y to the 10th. 2 squared became 4. X to the negative 6th moved down to my denominator, and y to the 10th stayed up top. Awesome job. Don't be scared to try it by yourself. Go ahead and be brave and pause the video and try to simplify this expression while I work it for you, and then check your answer. Hopefully you got to an answer of n over m cubed, and you are all set and ready to roll. So let's take a look at some of these expressions and see if we can classify them as greater than 1, equal to 1, or less than 1. So starting with 2 to the 0 power, anything raised to the 0 power, you got it, is equal to 1. 3 to the negative 2 power, this would be like 1 over 3 squared, and 1 over 3 squared is 1/9. 1/9 is certainly less than 1. So I'm going to put 3 to the negative 2 power in this bucket. 2 to the negative 3 power, I again know that this is going to make a